Hello everyone, and like Carolina said, my name is Wiktor Mazur, and today I'm going to tell you a few things about the bakery and how we managed to cook 2 games in one stove. So some of you probably wonder what is going on with this title. So today I'm going to unveil some secrets and tell you that bakery is a sweet name from Techland, so the company I'm working for, and the stove is our technology and processes we used to build those 2 games. And one of the game was the Dying Light 2 that you may know, and the second was our unannounced title that we're working on. So yeah, this is me, this is how I look. To all of you that are sitting in the further rows, this is how I look from the close-up. So yeah, a few things about me. Before Techland, I worked at Nokia. It was like 8 years ago, and I started to work there as a working student, then became a software developer, and ended up as a technical leader. While in there, I was working on 3 large projects. All of them was around the BTSs. You probably don't know what a BTS is. So it's a base transceiver station, and it's basically a box connected to the antenna thingy, usually by the road, that allows you to make your phone calls. So yeah, 3 projects, one of them web development, so the app for managing this software. Second, the embedded software for the BTSs, for which I wrote tons of C++ code and do tons of reviews. And the third, the testing framework. And the testing framework was awesome because it allowed us to make changes in our code without a need to upload it to the target hardware. So yeah, enough about Nokia, enough about BTSs, let's talk game dev, let's talk Techland. So I started as a QA engineer. I work on the GameDot and automation software technology. And you might heard about the GameBot from the Ilias talk about the quest system in the Dying Light 2. So basically, I was the one who was developing that software at that time. After that, I became a senior technology programmer and started to work on the CI/CD, build system, web application, and tools. And today, my talk will be around this topic. Yeah, a little disclaimer. Since I'm in Techland only 3 years, I wasn't taking an active part of development of a software that I'm going to talk about. But as a proud member of a DevOps team, I have a unique opportunity to work on this stuff on my daily basis. And as you might already notice, this is my first time on the stage speaking publicly. So please maybe... Thank you very much. Thanks. Didn't expect that. So, for the agenda, when we are going to talk about making 2 games at the same time, I'm going to divide this into 3 main topics. One of them will be the coordination of lots of people that are working together. So you know that in game development, beside the programmers, we have all different people, like the quest designers, artists, QAs, tons of people. So the first part will be about processes and workflow that allow us to build those 2 games. The second part will be about CI/CD and how we manage a large code base that was inevitable when we started to work on those 2 games. And the third, the final part, will be about the fault management and how we embrace the impact that that changes in one game made to another. And yeah, I would like to ask you to hold up to your questions till the end of my talk. So yeah, the coordination. The classic software approach that I was used to is basically to divide your system into the functional blocks, then establish an APIs, the interfaces between those blocks. After that, you're going to assign those to the development teams for them to be able to work on the features, and then release the features on given schedule, like a sprint or milestone. And yeah, this approach had lots of advantages. For example, your code, your features are going to probably be stable because you have time for scheduled releases, and it gives you time for careful writing the code and integration. Also, the quality of the code. You divided your system into the manageable parts, therefore, you probably can write some unit tests, module tests, and even integration tests, which in the end gives you a lot of confidence for changing your code. And the third part is obviously the reusability. Because you divided your system, you probably had to write some specification, right? You have the interfaces and boundaries, then you can reuse those software in other parts of your systems, future projects, or other systems. But yeah, it has a lot of disadvantages. For example, well, it's not a silver bullet. Nothing on life really is, right? So for first, the code must be independent. And you know that in our industry, we have physics, audio, animations, all other things that are highly interconnected with each other. Therefore, you cannot set a physical boundaries like the services because you will simply gain a performance issue which you simply cannot afford, right? So lastly, the game needs to be verified as a whole. Because with the game development, the form always goes with the function. And what I mean by that is even if you divide your system and test them and you think that it's all right, in the end, you need to confront them with the data because the assets are equally important as the code. And yeah, right now, I would like to tell you a few things about our technology stack. Well, at least a part of it. For first, we are using the C engine, it's our custom engine, and for content management system, we are using the Helix Perforce. And right now, I would like to ask you if you, personally, in your daily basis, are using Helix Perforce. Please raise your hand to do that, to show me. Whoa. Well, I didn't quite expect it. Even not only Techland people did that. So, yeah, I'm going to tell you why we are using the Helix Perforce. For first, it's support for the large files. And you know that in our industry, we have assets, and yeah, those can get quite big, right? So the native support from the Helix Perforce is awesome. The second are the streams, which are basically the great abstraction for branches that basically allows you to specify some relationship between the branches, between the streams. So for example, you can use only the subset of files from the parent stream in your child stream. This will be useful later. And the third fine thing about the Helix Perforce is the merge down copy app integration mechanism, which basically looks like this. You have the parent stream, you have the child stream, you're going to merge down everything from your parent stream into the child stream, and then you're going to copy everything up. So in the end, you're going to have exact copies of files of both streams. Yeah, I would like to also tell you that in the future of my talk, when you're going to see one arrow pointing down, a second pointing up, this will be integration part of the workflows. So yeah, the workflows before we started to work at the two games at the same time. So basically all the games before the Dying Light 2. It was simple, really. So all stakeholders like the game programmers, engine programmers, content creators were simply pushing their changes into one stream. And yeah, it worked. There were not so many developers back then, and only one game was developed at that time. But even then, there were some issues with stability. For example, when the engine programmer broke the engine, therefore broke the editor, our content creators weren't able to create the content. So what about working with two games? I see two ways of doing that. One of them is to fork. To fork your game, fork your technology, and work on them separately. And this is the way that we did it. We did that with all other titles before, and from what I know, many companies are still doing that. And the second way is to share. To share your technology between your games. And yeah, you might already imagine what we decided to do. Well, we decided to share the technology. And right now, I would like to tell you some things about our repository structure before I show you the workflows, of course. So we are using the layered architecture when the core engine, game framework, games and even the tools are stored in one repository, in one stream. They are together with the data. We are using the Helix Perforce to divide the code and data for specific games. And basically, we're using one technology for the two games. So yeah, the workflows. Our early approach basically looked like that. We tried to use some good practices from the general software approach, and we divided people to work on the specific streams. And we enabled them to push, to release their changes, their features on some schedule. So for example, the game programmers work on the specific streams and they release their changes weekly. And you remember the situation when I told you that there were some breakages with the content creation. So we solved that by releasing the technology, only the stable technology for the game data streams, for the content creators, for the content to be worked on. But yeah, our early approach, unfortunately, had some issues. And those issues were related to the feature releases, which were infrequent. Yeah, and right now I would like to tell you a few things about our engine. Like, its logic is data-driven, and the content depends on the technology. And what I mean by that, we are basically scripting our games into C++, which is awesome, but yeah, our technology now is, our features depends on the technology. So when we try to do the fast iterations on the features, which you know are quite important, it was difficult because you may see some conflict there. When we tried to release the engine on the schedule, and yeah, I didn't tell you one crucial thing. We solved that by letting the game and engine programmers to push their changes directly into the technology stream. So there were some issues with the integration because we tried to release those on a schedule and we had changes done directly in the one stream. So we even tried to establish some integration team to help with that integration, but in the end, it was a bottleneck. But yeah, we solved that. We improved our workflow in the way that we kind of came back to the basis when there was a one stream. So now we are using the one stream for the technology. We're releasing the stable technology into the data streams. So the games are released daily. I mean, the features are released daily. So we have fast iteration. And the changes are small and frequent. Therefore, the integration is easy. And this concludes the workflows part of my talk. So yeah, we created some workflows. Now let's talk CI/CD and the large code base, how we manage it. So just to tell you, just to show you the scales of the games that we are working on, for example, we had an expand rally with around the 1.5K meshes. Then we released the games of the similar size, like we had the Call of Juarez 1, 2, 3, Dead Island. And after that, the Dying Light came, our first AAA game with over 10K meshes. And after that, the Dying Light 2, which doubled that number. And then, just to show the scale, our unannounced title is aiming to be at least as big as a Dying Light 2. I probably don't need to tell you that with the scale of the game, the complexity of the CI/CD grows. So, for example, we had an expand rally where there were simply a bunch of batch files executed directly on the developer's PC. Basically, there were no CI/CD. Yeah, it worked because, well, there were like 20 people working on that project, 20 developers, and it was developed only for one platform, so it was PC. And then the call of Juarez came when we increased the number of target platforms by one. So now we releasing the games for the PCs and Xboxes, and this was the time when we introduced the first CI/CD. So we introduced first automation server, and it was a Hudson. And after that, the Dead Island, when we increased the number of platforms to 3. Now we have the PCs, the Xboxes, and the PlayStations. So we needed to do some transitions from the batch files, and we embedded the complex logic into the Python scripts. And yeah, you probably know that the Dying Light 2 wasn't our first game. Yeah, there was some Dying Light. And we inherited a lot of stuff from that. We inherited stuff like unit testing, building the code, building the assets, basically releasing the whole game. And now we need to do it for 2 games stored on the large repository for each game, for each available platforms, for production, prototyping, QA, and even outsource. And what we decided to do, we took some good practices from the general software approach, and, well, we applied it to the pipeline systems. And it turned out great. So what we came up with was a PYMODULES library divided into 2 parts. One of them was the Jumble, when the code, resource build, packaging, patching, fault handling, and even the game automation was stored. So it contained the core logic for the pipelines. And fun fact, when I was working on the QA, this was the main part when I committed my changes. The Jumble had one fine thing, because, well, the unit tests were needed, so were mandatory here, and there were even some integration tests. So we released stable functionality from the Jumble library, but some of you might working on the CI/CD, so you know that you have to have somewhere some glue code. So the cookbook with the recipes for our pipelines was the place to store that glue code. And yeah, now we have 2 games stored on one single repository, and now developers are pushing their changes. For example, developers are changing the assets. And what should we do if the assets are changed? Well, we probably should rebuild them for them to be later used. And we need to do it on some automation server, on some specific job. And what should we do if the developer changes the Dying Light 2 code? Well, we should build this game, build the code, and we should run some unit tests. And what should we do when the core part of your system changes? Well, basically, we need to trigger everything. So we need to test the engine, game engine, all the games, everything what is dependent on that. So we need to trigger correct automation server. And I see 2 ways of doing that. One of them is to use the SCM polling from the Jenkins, and it worked on all our previous projects. So for example, it worked on the Dying Light. But then, even then, we started to see that there were some computation overhead. So we started to look at the other things. And we started to look at the SCM hooks. In our case, there were the helix perforce triggers. And yeah, they were fast, they were nice, there were no polling, and they were tool independent. And what I mean by that, we could trigger different automation servers, so in our case, different Jenkinses from them. But there were one challenge we need to solve. So the logic should be simple. The logic in your triggers should be relatively simple because you don't want to wait for each time you did a change to complex logic to be executed in the trigger side. So what we did, we created a Django library. We call it an unleash. And the unleash was connected to the perforce triggers in the way that is as simple as possible. Basically, when the change happened, the perforce trigger told the unleash that, well, the change happened. And that was it. so there were no overhead to the system. All of them was managed independently because it was, well, Django application. We were able to write some complex logic in there and set all the things that I was talking before. So when the assets are changed, we need to execute correct automation server. So, for example, we need to build the asset. And, well, you know the drill, right? So finally, our two games in one-stop approach looked like that. We had the PYMODULES library with the core logic for the pipelines. Everything was scheduled by the Django web application, and we had some few automation servers, jobs related for everything, and everything was run in the PCs and consoles stored in our server room and managed by our IT department. And yeah, that concludes the CI/CD part. Okay, so we managed to do some processes. We built some CI/CD quite complex. Well, now we need to do something with the faults which were, well, inevitable when we made the changes in two games at the same time. So in the early stages, the faults were there, they were visible, but they were simply not tracked. And like you can imagine, the untracked faults like to stack up. And people were simply accustomed to the editor on the game crashes in the way that the content creators had two instances of the editor opened, and the second was just for there if the first one crashes. So yeah, we needed to do something with that, and we needed to do it automatically. And what we did, we created another Django application. And well, you may see the pattern here that we like to solve our problems by creating the new Django application. But yeah, trust me, this was kind of different. Because this one had the ability to report all the events from all parts of our systems to some integrations like the Slack or the Jira or email or other. It was able to feedback the users through the communications channels like the Slack and to visualize those in internal browser access through the web. And yeah, we call it the CHUTE because all events from all our applications, like the game editor and even the Jenkins pipeline, went down directly to the CHUTE. Remember the situation about the crashes and the content creator. Now we need to catch those crashes. And I see two ways of doing that. One of them is to launch your application with a debugger, and the second is to embed your exception handler directly into your application. While the first works every time, the second is sometimes unable to detect a Stack Overflow. Well, what I mean by that is when the Stack Overflow happens, sometimes you will totally lose control of your application and it's gone. And the second doesn't work on consoles. Doesn't work on consoles. And yeah, what I mean by that is you cannot simply have one debugger for each platform. While the second one, well, works every time because, well, it's embedded in your application. And how can we? Well, we decided to embed our exception handler in the application. And how we do that? We use the structure exception handler mechanism from the Microsoft, which basically looks like that. You have the try catch statement directly in the main function of your application, and now you know that the crash happened. We prepared some C++ library for the CHUTE to send those events to our application. It was accessible from all our applications, C++, in our company. And yeah, the crash happened, we sent it to the CHUTE, and now the magic happened. So, for example, the information about crash was sent immediately to the Slack channel for the developers to be able to do something with that. And also, it was sent to the Jira. I mean, when the crash happened, the Jira was created. And just to not overblown our system, we calculated a hash for the crashes. So if the crash of the same time happened, we know that we should attach it to the already existing Jira and not make another create another. And yeah, I told you that all events were saved and ready to be browsed. So like now, I would like to show you how this browser, this dashboard looks like. So yeah, the situation before the Dying Light 2 release, so it was January 2021, we had some 30 crashes on average, and yeah, well, not great, not terrible, right? So the situation before the release, we came down to the 6 crashes per average, which, to be honest, is awesome, and I see a great improvement of the stability of our applications. But yeah, the crashes aren't only the soft faults, aren't only faults that we are catching. We had some soft faults, and we call them assertions, and those were set by the developers directly in our applications. And when the assertion happened, when the soft fault happened, it is sent to the CHUTE via the CHUTE library, and now it's ready to be browsed on. So the similar situation, like with the crashes, but for the soft faults, January 2021, we had some 5K, 7.5K soft faults on average, but those aren't important. What is important are the 2 spikes that you see there. Those one enabled us to see that some problem happened and we could act immediately. And similar situation, the post-release, after the Dying Light 2 came, well, the count kind of increased, but there were no spikes, so great. And by the way, yeah, we are working on that. I needed also to blur some names there because, well, it's a code name for our unannounced title, and yeah, it's super secret, and I couldn't simply show it to you. So yeah, in the summary, our new workflows allowed us to synchronize our changes on a daily basis. Our CI/CD enabled us to produce some builds for the tests, so the fast iterations were there, and the tools such as CHUTE enable us to contain the changes that one game made to another. And yeah, by the way, some software, well, most of software I was talking about was developed thanks to the European Udemy project. And thank you. Well, wait a second. I need to tell you that we are hiring, and you see a booth, Techland booth there. So if you want to work on such technology, you're welcome there. And yeah, thank you. That's all.
Thank you, Wiktor. And do you have any questions? Please.
Now it's a great time to ask your questions if you have any.
Do you have? No? Yes? Okay. Come on.
Hi, thank you for your talk. And I have a question about that. I saw that you have an engine, right? That is shared between the 2 projects.
Yes.
And do you have any, I don't know, approach how to handle engine changes per project? For example, you have Dying Light 2 and you have, I don't know, some engine changes and you want it that way, and you do not want to interfere with another project.
Well, the engine is a shared part, so it cannot be really separated, right? Because like I told you, like I showed you, we have 2 games, both of the games developed together with the engine. So yeah, we do not have such a thing. And I personally don't see the reason why we should. Maybe you have some advice.
Maybe not, but no, I'm just asking because, you know, game dev is so wide and full of, you know, treated cars, many patches and so on. So I will glad to hear another approach how to handle such mess. So
yeah, basically we use the CI/CD to contain that.
Okay, thank you.
Thank you, Konrad. Okay.
Oh, Gabriel.
Gabriel, yes?
Hey.
Yeah. I should go.
Thank you.
Hi, I wanted to ask about the perforce triggers. Are they used just to trigger the mechanics, or are they actually stopping the developer because some things need to validate his commit?
Yeah, we have two ways of doing that. One of way for changing our changes is directly in the CI/CD tool. So before you are doing your changes, you have the ability to, the tests are executed and the validation is there. But even if you validated your changes in pre-submit part, you want to test that anyway. You like to test it after the integration also. So this is how we use this mechanism.
Okay, thank you.
More.
More. No, do you have? Okay. So
Well, okay, so thank you.
Thank you very much.